Hello and welcome to the Calculating Accelerated Motion video tutorial. Here we have a plane that's flying at 180 miles per hour, and it only has 2 miles to slow down to 10 miles per hour. And we're going to calculate the acceleration of that plane and how long the plane is accelerating for. Let's see. To start, the first problem is that we've got this 180 miles per hour and the 10 miles per hour and the 2 miles, and that all needs to be meters and seconds. So we're going to get our conversion factor, and 1 mile per hour is equal to 0.4470 meters per second. And I got that by just looking it up in a book. You can look that up in a book or online and find what that is. So now we're going to change our 180 miles per hour into meters per second using our conversion factor. So when you're using the conversion factor, you're either going to multiply or divide by this number. And the way I think about it is, well, you should end up with more miles per hour than meters per second. I mean, just look over here. This is a smaller number than this. So when I multiply or divide, I want to end up with a smaller number. So if I was to divide by this, I'll end up with a bigger number. So I'm going to multiply by this, so I end up with a smaller answer. So 180 miles per hour is going to get multiplied by 0.4470. And that's going to give me 80.46 meters per second, which is a smaller number than the 180. We're going to do the same thing for the 10 miles per hour. We're going to multiply that by the 0.4470, and that's going to give 4.47 meters per second. Okay. Now we need to convert the 2 miles. So 1 mile is equal to 1609 meters. So that means that 2 miles is just double that. So 2 miles is 3218 meters. All right. Now that we've done that, we can actually start the problem because we have everything in meters and seconds. The first thing to do is to make the list. So here's the list of the relevant variables. So x, x naught, v, v naught, acceleration, and time. Alright, so we're just going to plug in what we've got into these. So the plane is going to start, well, it doesn't say where it starts, but we're going to say it starts at 0 meters because that's a nice, easy starting place. And the plane is going to reach a final position of 3,218 meters. Separate that. Alright, the starting velocity for the plane is right here, this 80.46, because remember, it starts fast and ends slow. So that's the starting velocity. Its final velocity is the slower speed here. The acceleration we don't know, and we actually don't know the time either, and we're not going to leave these blank because leaving them blank implies that you're not sure what's going on. Put a question mark to show we actually know that we don't know this information. So those are unknown. Alright, now that we have this, we are going to start plugging them into our formulas. So we'll start by just writing down the 3 kinematics formulas that we have to work with. Whoops. Plus v naught t plus 1/2 at squared. Alright. The next equation is v equals v naught plus at. And our last equation is v squared equals v naught squared plus 2ax. Alright, now we're going to figure out which equation we want to use. Well, we don't have an acceleration and we don't have a time. So any equation that uses both acceleration and time is not going to do us any good because we'll end up with 2 unknowns in one equation. So there's acceleration and time right there. That's going to cause a problem. And there's acceleration time right there. That's going to cause a problem. So this is the equation we want to use because it has acceleration but no time. So that's a good one. So start with this equation. Whoops, where'd the back of that go? All right. And now we'll start plugging stuff in. So v squared is, well, remember that's our final velocity. In fact, you don't even need to think about it. We already made our list here, so we can just bring the numbers over. So 4.47 squared equals the starting velocity squared, which is 80.46, plus 2a. And this x, by the way, is actually delta x. That's the change in position. But as long as your starting position is 0, this is basically the same as just your final position. But be careful, if this is not 0, you got to subtract these to figure out what goes in there. So the change in position is that right there. And now we just got to do math. So we'll square this. That gives you 19.98. And then we'll square this number, and that gives some very large number, 6473.81. And then we're going to do 2 times this number, and that's 6,436. Now we're going to subtract this from both sides, so we should end up with a negative number, and we do get a negative number. Negative 6,453.83 is equal to 6436a. Now we're going to divide both sides by this 6436, and you should get a equals negative 1 pretty much exactly. So the acceleration of the plane is negative 1 meter per second squared. So you're going to lose a meter per second every second. Now let's figure out how long that occurs for. So now we have an acceleration. It's right here. In fact, let's sure we know that that is an answer. And now we're going to find time. So we can use either of these two equations. I'm going to choose this one because it is shorter, which makes me think it is easier. So v equals v naught, plus at. Plugging in, our final velocity again was 80.46. The starting velocity was 4.47 plus negative 1 times t. So subtracting this from both sides, oh whoops, I have these backwards. This is our final velocity, was the smaller velocity, and this 80.46. That was the starting velocity because we went from fast to slow. So subtracting, you're going to get negative 75.99 is equal to negative t. So that makes the time equal to 75.99 seconds. And just for good measure, we'll just put that in minutes. So just subtract off 60 seconds for 1 minute. So that's 1 minute, and we'll just round off that last hundredth of a second. 1 minute and 16 seconds for the plane to come to a stop. Thank you for watching the Calculating Accelerated Motion video tutorial.